Hello friends, this is Sumit, and in this video lecture we'll discuss about an important topic in mathematics, that is integral calculus. Here I will not be solving any problem as such, but I have come here to discuss the importance of this subject in real life by illustrating with the help of a real life example. I have often found students solving very complex problems without knowing the purpose of it. So lastly, I would say that it is a very important tool in our hand, and let us learn how to effectively utilize it. For which I'll take a real life example. A goldsmith lived in a city, and he was a famous goldsmith, and a person came to him with an order for placing an order of a crown for the deity to be installed in the temple of his house. So he gave this model to him and asked the goldsmith to make exactly as per this dimension. Okay, so this is the dimension of the crown that was to be made by the goldsmith as ordered by the person who came. Okay, so now since corona situation was there, the liquid cash in hand with the goldsmith was too less, and he wanted to exactly optimize the amount of gold to be purchased. Okay, then he tried to calculate as to how much gold he need to purchase in order to execute the order. So he developed he expanded the model given by the person, and a developed view was created. So this is called a developed view. Developed view was created, and he tried to, with whatever knowledge he had, to calculate the surface area of this developed view, okay, of the crown to be made by him. Okay, so what he did, he thought that the crown looks somewhat like this, and if we approximate this bottom part, which looks like a rectangle, and top part which is looking like a triangle. So he tried to approximate and found out the surface area required. Okay, so he tried to calculate the surface area that is required to execute the order and amount of gold to be bought. So area of rectangle plus area of triangle, he tried to calculate. Now area of rectangle, you can see here, is 100 into 25 plus area of triangle is half into base into height. Base is 100 and height is 25. Okay, so he could calculate the surface area to be 3750 square meter. But actually he was worried that in the surface area calculated by him, he could not account these two surface areas, which was left like this. Then he called his son, who was studying in class 10th, and told him that, son, you have been studying since so long. Can you help me calculate the surface area of this surface? I have to buy this gold, and I had limited money only, and I want to buy only the optimized amount that I could. So he told that, Dad, I will help you somehow. So what he did, is a very intelligent student, and what he did is drew a graph. Okay, and he actually had studied in his class that area of rectangle is equal to length into breadth, that he had studied. So he tried to approximate this total surface area as number of rectangles. So he took one rectangle here of this dimension, other rectangle here of this dimension, third rectangle here of this dimension, fourth rectangle also he took here of this dimension. So likewise he started approximating the surface area in terms of rectangles like this. So he made an approximation like this to calculate the surface area, because he was studying class 10th only, and up to his knowledge he knew only the area of a rectangle. So he could approximate somehow the area that is given by his dad in terms of rectangles. Okay, so as this side is in symmetry to this side, see this side exactly symmetric to this side, so he tried to calculate this area and multiply by 2 to get the other area, total area. Okay, so with this approximation he went ahead, and now what he found out, I'll just see. Now area as he approximated was, first rectangle area, how much it will be? 25 into 5 is the x-axis, so 25 into 5 plus next 30 into 5 plus next 35 into 5, next 40 into 5 plus again 40 into 5 plus 45 into 5 plus 45 into 5 plus 45 into 5 plus 50 into 5 plus 50 into 5. Okay, so see, he approximated this surface area on the left side to be some rectangles, and he calculated simply the area of these rectangles, length into breadth. That is, see, 25 into 5, 30 into 5, then 35 into 5, then again 40 into 5, 40 into 5. Like that he calculated approximate surface area with whatever knowledge he had. And you know what he got is, we'll see as to how much surface area he got, was 4050 square meter. So his dad was a bit convinced, but even though he was worried that this all area is not covered by the approximation that his son has made. See, this area was not covered, this area was not covered, this area, this area, this area. So these all areas were still not covered, and he was still worried as to how would he approximate the exact area or exact amount of gold that he had to buy. And here this whole had to be multiplied by 2, because he had calculated only on one side, so other side will be a mirror image of that, so multiplied by 2. Okay, so this is the area. So what his dad had calculated is here. His dad had calculated a surface area of 3750 meters square, and he calculated a surface area of 4050 meters square. So it was a slightly better approximation. Then comes the catch. Actually, Goldsmith had a daughter studying in class 12th, and she had studied integral calculus. So she actually the same time came from school, and she saw his brother and dad struggling with the problem and trying to calculate the exact surface area of this surface. Okay. So now what she did, she thought that I have studied integral calculus and I can somehow calculate the surface area. Let me think. So she took this problem and went to her room and tried to plot this curve. See, here this is a curve. Okay. So tried to plot this curve in her laptop and found that, this curve, or the surface area of the curve, is which her dad was trying to calculate, is exactly simulated by this equation. So she was delighted to find out that equation of this curve she could actually plot. So what is the equation of this curve that she found out was y is equal to minus x minus 50 by 10 square plus 50. So this is the equation of this curve that she found out. After finding out this thing, actually she was very delighted because she had studied integral calculus and now she was confident that she can find out the exact surface area of this surface. Okay, so now she started with the problem. So see what she did here. She knew that surface area can be calculated by integral calculus, and she integrated y with respect to x from, see, the function is in terms of y, okay, and she is integrating along the x direction by taking limits as from 0 to 100. Okay, she took limits from 0 to 100. So y she could replace by this equation. So this equation was 50 minus x minus 50 by 10 square dx integral from 0 to 100. So she expanded it and wrote 50x minus x cubed by 300 minus 50 square x by 100 plus x square by 2, which can be, after integrating she wrote like this, under the limits 0 to 100. Now she applied this limits and found this 50 into 100 minus 100 into 100 into 100 divided by 300 minus 50 into 100 divided by 100 plus 50 into 100 divided by 2. So here we can see that we can cancel these two zeros and this will be 33.3, and here we see that 100 will be cancelled by 100, and here this, sorry, it was 100, and after cancelling it became 50. So finally she could do some arithmetic and she found out is 2500 plus 5000, which is equal to 4170 square mm. Okay, this all was in mm square only. This also was in mm square because the dimensions were in mm. Here also it was mm square. Okay, so actually I'll once again take a review of all the three approximations that were made. So this was the first approximation wherein only a rectangle and a triangle was taken and found out to be, area found out to be 3750, and actually his dad was worried about these surface areas which were not accounted earlier. Later his son, who was studying in class 10th, approximated the surface area with the help of rectangles because he knew the surface area of a rectangle, and he approximated this whole area in terms of different rectangles, and he calculated the surface area of this surface to be 4050. But when this girl came from school, she understood that it is a problem of integral calculus and she could with the use of her knowledge, define y as a function of x. When y is defined as a function of x for this curve, she could easily integrate and found out that this much surface area actually is required. So see the change in the approximates. His dad approximated 3750 square meter. His son, a slightly better approximation, 4050. But she calculated exactly how much surface area of gold is required to make the crown of the deity, to be given in the order. And this surface area can be easily multiplied by the thickness and density of gold to know the mass of gold to be ordered. So in this way she could solve her dad's problem, and this example can be taken as a practical as a real life example to understand integral calculus. Okay, so this is Sumit signing off. If you have liked the video, please click on the like button, comment and subscribe to my channel. I'll be coming up with more such videos. Thank you.